Saving schemes. So with a savings scheme, what you do is there will be an initial lump sum put into the savings scheme. Usually, sometimes there isn't, in which case it would be zero. But then you make these regular payments every month or every quarter or whatever, according to the question. And those go into the savings scheme. And then obviously you add all the compound interest and everything. And then eventually at the end, you get a payment, okay, at the very end. So I'm going to put in the initial lump sum as a negative and the payments as a negative because they come from your pocket. But at the very end, when the bank pays you the money, that's going to be a plus. Okay, so let's look at question 1. So go to Apps, Finance, TVM Solver. Mr. Jones starts a savings scheme. He invests an initial lump sum of $5,000 with monthly payments of $100. Interest is compounded monthly at a rate of 5% per annum. Find the value of the investment after 8 years. So let's start from the top. We know it's 8 years and it's compounded monthly. So this is going to be 8 times 12 is the total number of payments. So that's 96. It's monthly, so I'll just go down here now and change these to 12 because it's 12 times a year. Interest rate is 5%. Present value is the initial lump sum invested into the account, so that's going to be minus 5,000. And she's also going to make payments of 100, so I'm going to put that as minus 100 because she's paying those amounts, so that's coming out of her pocket, so they're both negatives. Future value is the value at the end of the investment. So this is what we're trying to find. So press alpha solve. So she's going to make or get back at the end 19,226.98, and that's positive because she's getting that money at the end. Okay, question 2. Miss Smith is saving for a house. She needs to save enough for a deposit of $20,000 and can afford to save $1,200 per quarter, which she will put into a savings scheme which offers 6% interest per annum compounded quarterly. Calculate how long it will take Miss Smith to save up the deposit. Okay, so this time she's going to save $1,200 per quarter. So her payments will be minus $1,200. Notice that she doesn't put an initial amount into the bank, so that's going to be 0. But she wants to have, at the end of this scheme, she wants to have 20,000 coming to her. So that's going to be a positive for her. And then we just fill in the other numbers. So the top one is the one we're trying to find actually. Interest rate is 6%. Notice that everything is compounded and payments are quarterly. So these both need to be 4. Okay, so the thing we're trying to find actually is the top number. So we do alpha solve. So it's 14.99. But don't forget, this is the number of quarters, yeah, that she's actually paid. She's basically going to have to do like 15 payments in order to get over the 20,000. So, but that's 15 quarters. So obviously we need to divide by 4 if we want the answer in years. If the question says number of quarters, then it would be 15. But now one thing we can do, if you go second quit and go to Apps, Finance, and go across to the vars, it remembers the values of these things. So for example here, n, instead of having to write that number down and then divide by 4, we can just do n divided by 4, and we'll get that it's basically 3.75 years that it's going to take her to make the 20,000 if she invests $1,200 per quarter with 6% interest.